Hey there, Jakob here, and as you can see, I'm in the process of making a neck for a bass guitar, and I wanted to take the opportunity to talk about it and share with you why I'm doing what I'm doing here. So you can see there's a lot of kind of inlays in the neck, and yeah, it's a little bit more complicated than you might think. So I want to explain why I'm taking this extra effort to make all these inlays. And yeah, if you want to see how I make this neck, there is a build video coming up, how I make this neck, but also a whole bass guitar. There's a little teaser. It's gonna be a continuation of the last Canna Evo build, so with the wooden body and the relief on the back. I improved the design a little bit, so yeah, it will be very interesting to see that. Also a bass guitar with a arch top, and it's a carved arch top this time, so not laminated. Yeah, a lot of things going on there, but yeah, stay tuned for that. And in this video, yeah, let's talk about the neck design. So yeah, let's start with my wave joint here. And you might be familiar with a scarf joint, or the principle of a scarf joint. And what it is basically you have your wood blank, and then you cut it open and you turn it around and place it like this. And now you have your neck angle inset. And one reason for doing it is to save some wood. So yeah, you don't need to have like a 5 centimeter thick piece of wood, so it saves some wood. But also another benefit is that now the grain fiber, they run now in the direction of the neck, and therefore or the headstock, and therefore the headstock gets yeah, stronger. And yeah, I'm doing these this wave joint for the reason of because I'm doing it with the CNC. You can see that I machined most of the things, and yeah, with this wave joint you can see that the headpiece is going underneath the neck piece, so it's kind of, when I put it together, they kind of lock in place. So I machine these kind of blanks separately, and then when I glue them together, they are very fixed in a position. And I have like these holding pins here, like you can see on this neck. They're like these holding pins. And when I machine it, I have to place it like on the CNC. First do the outer contour here, then flip it around, do the back, then do the back of the headstock, and then the top of the headstock. And every time I flip it around, you need to have like the perfect location and distance, and also the angle of these two pieces, or all the holes kind of in relation. And with a fan fret like this, it's even more complicated, because the neck is not just tilted in this direction, but also like in this direction. And yeah, it gets very complicated to have like all the things lining up. And as you can see, there is like a little bit of kind of thing not perfectly aligned. So yeah, it's 1/10 of a millimeter, but that's okay, because I do a lot of work by hand later on, and yeah, that's perfectly fine to do that. All right, moving on to the inlay in the headstock. So you can see it's starting here, and yeah, it's going all the way around the headstock. And basically I'm doing it because yeah, of my open headstock design. So to kind of illustrate a little bit what the problem is with these open headstock designs. So you have the headstock like going out like this, and then you have the tuners. And now if you apply the string tension, it's kind of rotating inside here, and then it's pushing outside, pushing like outside here, and in the middle kind of creates like this pressure where the necks would crack. And actually I've built like 50 guitars like this without the inlay, but I always used a maple or like some hardwood that isn't cracking that much, and it's quite sturdy. But one time I used cedro, and yeah, I got this crack in the middle, and yeah, that's basically why I'm doing it. Lets me sleep better at night, making sure the headstock is nice and secure, so it can't crack. Also, one time I basically had a guitar finished, and then I had to chop off the neck because yeah, when I pressed in the tuner, the hole is like supposed to be 10 millimeters, and the bushing you press in is like 10.1 millimeters, so it's a little bit bigger, so you can kind of press it in, so it's nice and snug. But this is roasted maple, and roasted maple has like the downside of being very brittle, and yeah, it wasn't exact enough. So yeah, basically I've ruined a completely finished guitar. And then I had to replace the neck, chop off the headstock. And yeah, this is a reminder of being very careful with roasted maple. And that's why I'm also doing like this inlay. And yeah, maybe you can see how deep it's going. So it's like not completely to the bottom, because I want to have some room to work the material. But yeah, almost. So this is bass guitar, so the hole is much bigger. So yeah, there's like 5 millimeters left, but that's plenty strong. And it's also securing this part of the neck. You may be familiar with guitars that have a volute, and the volute is kind of securing or making this part of the neck stronger. And I talked to some guy who made some reviews for guitars, like thousands of guitars, and he told me that the most common problem with sanding guitars when they are that damaged is that the neck is broken, because they're in the case, and they lay on the case like this, and when the case falls, it gives like this hit, and then it breaks on the neck. And yeah, this is basically preventing that. Also with the inlay in the neck, and yeah, the joint here, there's like more gluing surface, so I think it's a little bit more secure as well. So moving on to the neck, yeah, I have a inlay in the neck and also in the fretboard here, and there is like an insert here which is made from Paulownia, which is a very light wood. And then I have, I think, 4 layers of 150 gram carbon fiber in there. So yeah, I'm experimenting a little bit with how much carbon fiber I'm using, but that's about what I'm using now. And also in the neck, I have some carbon fiber. So I'm using, this is for like guitar fretboards, carbon fiber plate like this. So I have like a big plate. I cut out a lot of these carbon fiber pieces, and this way it's quite affordable, so it's like $5. And then I also fill it up with some light wood, and in this case there's just a veneer, because yeah, the carbon fiber is basically almost all the fretboard, and yeah, it's pretty sturdy. And yeah, there are several reasons why I'm doing these carbon fiber inlays. So one reason is the stiffness, and yeah, I have my whiteboard here to talk a little bit or explain a little bit about how stiffness works, because yeah, it's maybe not very common knowledge, but if you have a piece of wood and you put some pressure on it, or a piece of material, doesn't matter, and it bends. You see that the upper portion here gets compressed, so yeah, it gets shorter, and the bottom gets stretched. And in the middle, not exactly, like in the middle, yeah, it must meet somewhere, so it stays the same. It doesn't move at all. And if you look at a fretboard or like a neck, you have the neck, and then you have the fretboard. And usually, what builders do is they put like these 2 carbon fiber rods in there. Yeah, so I've been doing this basically for the first 50 guitars or so. Before I had a CNC, I also put in these carbon fiber rods. And if you look at this, so the carbon fiber rods, they are basically in the center, and in the center it's not changing the length, and therefore the added stiffness in the center basically doesn't do anything. So yeah, it's basically useless. It's not useless, but yeah, it helps like deformation and stuff. But for stiffness, it's basically not really doing anything. So what I'm doing is you have the neck, and then I put in this carbon fiber like on the very bottom, so there's like 3 millimeters of room, and then I have like the carbon fiber on the top like this. So the compression part is very strong, and the stretch part is also very strong, and yeah, both together they make a very strong and sturdy neck. Of course, you have a truss rod also to help with that, but in this case it's more for kind of adjusting the relief a little bit. Okay, so that's the first reason is the added stiffness. The second reason is weight relief. So I told you that the inlay is very light wood, and if you are using pretty heavy wood like a maple here, you save about, on this neck, probably 80, 90, 100 grams. I didn't kind of calculate it, but it's about that much. And for the fretboard, it's actually a little bit more, depending on what wood you use. But if you use like ebony, it's quite a bit of weight relief. And yeah, it's always nice to have a nice and light neck, especially for a bass guitar where you have like this big leverage. And then I'm also using very light tuners, so you don't get like this neck dive. So that's the second reason. And the third, and I think the most important reason why I'm doing is to kind of prevent any kind of deformation or twisting, turning of the neck over time. So down the road in like 10 years or something. And there are like 2 factors to this. So one factor is called creep. So I used this spruce piece on a go-by deck, and yeah, I used it, and now it's like has a bow in it because I used it to push down things. And yeah, that's happening also with the neck. As you put pressure on it over a long time, it kind of holds it in the formed state. And yeah, if it's kind of going on, you get like banana neck, and get a horrible action. Of course, you have the truss rod, but the creep is a thing, and also with different woods, there's more creep. I think maple is like pretty bad when it comes to this. And yeah, so that's the first reason. And the second reason is like deformation because of the wood. So when you cut the wood, there are internal stresses that get relieved when you cut out the shape of the neck, and then when it dries, yeah, these stresses also kind of show up maybe like 10 years later. And that's also the biggest reason why you have like very old woods for guitars. So you have like these tone woods which are like 10-20 years old, and they are very dry. So the main reason for this is that they don't deform. And usually when you build a neck, you want the fibers to be upright, so it's called quarter sawn. And if you have it like flat sawn, so imagine like this plank, and if you have it flat sawn, it moves in this direction, and quarter sawn it moves mostly sideways, and yeah, this leads to this kind of deformation, and yeah, you don't want to have it. And if you have like quarter sawn wood, let's make it like this. Yeah, it kind of maybe bends to the side in any way, and that's not that big of a problem. Maybe the kind of spacing between like the low and high E string to the edge of the fretboard changes a little bit, but yeah, you don't get any problems from that in terms of action of the guitar. And yeah, that's why mostly you need to use quarter sawn woods for a neck. And because I kind of remove most of the wood of the neck, and I put like carbon fiber area, basically it doesn't matter if I'm using quarter sawn wood or flat sawn wood. And basically also the species of wood or how strong it is, it doesn't really matter. So it opens up like a lot of possibilities to use different woods. Also for this reason, yeah, I couldn't use much more like common woods like mahogany and cedro or something like that, but now I could use it. Okay, let's talk a little bit about the architecture of the neck. So we don't want to have the neck to be perfectly straight. So if you have a neck, I'm exaggerating, but yeah. So the body of the guitar, and here's the neck, and you want to have like a little bit of a back bow in there. It's called relief. So if you press down the string at the fourth fret and at the neck joint, you want to have like a little bit of room, like 0.1 millimeter or less, depending which string. You have like a little bit of room, and that's because when you play the string, it kind of bounces like that. And the highest amplitude is like in the center, so you want to have like this back bend, and then later when you play like string like this, there's a little less, and then like this. And yeah, so basically you want like this slight back bend that's very continuous. There's something called I think a fade off or like fade away, something like that, which means that yeah, it's flattening out here. So it's like a little bit flattening out, or even going down a little bit, and that's because yeah, the frets get closer and closer, and there's this effect that yeah, you need less of this kind of backbend down the neck. And yeah, the biggest problem with guitars is that you actually have like this stiffness change here. So you have the heel, and here where the heel is like this, the neck is very stiff, and here it bends through, and then you get like this hump. As I said, you want this fade off, but it's very common that at the neck joint there's like problems because yeah, the stiffness difference there. And yeah, other companies I've seen like Furch, they have like this aluminum piece in here, kind of extends the stiffness, but yeah, I think yeah, it kind of pushes the problem further into the neck and doesn't really help that much. I haven't played one or seen one personally, but I think yeah, it's not ideal, and yeah, Also McPherson, I think they just put like carbon fiber all through the neck, and I think that's fine, but you want to have like a little bit of backbend, and you could use like a complete carbon fiber neck and then put the relief into the fretboard, or use a CNC to put the perfect relief in there, and also dress the frets with like a plaque machine or something, and to get like this nice relief. But yeah, I'm using the carbon fiber in here, which makes the stiffness very continuous, and yeah, there's not much of a jump here. And also because I'm mounting the neck onto the body here, I don't have really a heel, and there's not much of a stiffness change at this area. But yeah, it's a little bit because you have like the bolt here, and it's pivoting on this part, so there might be a little bit of a problem. But with the carbon fiber and fretboard, yeah, it's basically, yeah, much more consistent. Okay, so lastly, I want to talk a little bit about how I'm fixing the neck, because yeah, I'm bolting on the neck now. So there's like this insert of brass, and then I have a M8 screw in there. And one reason for that is, of course, you can take it off, and easier to repair or adjust or do anything. But another reason is also that I want to have adjustability of the neck. So here's also a guitar I'm working on. Yeah, also the new improved design of the back here. And I put on the neck without the top, and you can see there's the bolt holding it down, and then there's like a second bolt, which is like in this neck block here, which also laminated with carbon fiber, everything carbon fiber, and this bolt is pushing up here, and the string tension is pulling up the neck here, and now it's pivoting like on the front edge here, and I could go in there with a hex key. So now I'm in there with the hex key, so I can reach it through the side port, and I can turn this. Yeah, it's quite some pressure on there already, to slightly tilt the neck. So it's actually this much is basically changing the string action by like 5 millimeters or more. So it's really just like half a rotation is usually enough to change the string action from like 4 millimeters to 2.5 or something. And yeah, this way you can also remove the neck and adjust the height. And yeah, one more thing I want to mention is, because I mount the neck on the top like this, I don't send these parallel, so the bottom side here is a little bit tilted, so the neck is like tilted towards the player, and first it does that the fretboard, you don't have to kind of lean over to look at the fretboard, so it's nice kind of turned towards you, so that's really nice for like playability and the visual, and like for your posture, you can sit there and look at the fretboard without like bending forward. And another benefit is that you want to have more action or more kind of room on the bass string than on the treble string. And yeah, when you look at like the strings here, so the treble string and the bass string, so you want to have like more space here. So when I do it like asymmetrically like this, now imagine neck is like this, and the result, if you think about the top beam on this plane, is that the distance from the at the bridge is basically the same. So for classical guitars, you want to have like 11 millimeters distance from the string to the top, on the high E string as well as on the low E string. And by tilting the neck, I get like this benefit of having the same height, and therefore the same torque, and therefore the same force of the string pulling on the bridge, and also like the more of relief or more action on the low E string than on the high string. And yeah, so that's like 2 reasons to do that. And yeah, so a lot to talk about next. I could go on forever, but that should be enough for today. I hope you found it interesting. Let me know in the comments if you want to hear a little bit more explain videos like this. I've done a lot like when I started out, but kind of stopped doing it. And yeah, there's a lot of topics to kind of talk about and dig in and kind of nerd out about. And I hope some of you found it interesting. And if you do anything with this information, basically just doing like an insert like this in your fretboard, you can use like a copy router. It's super easy to do. I think will give you like most of the benefits of all of this. So I think this should be used, not like these carbon fiber rods. I think this is like much better. And yeah, it's pretty easy to do. Don't need a CNC. And yeah, if you want to see how I'm doing it, stay tuned. Build video is coming up, maybe a couple of weeks, hopefully. It's taking a long time, but yeah, that's it for today. Thanks for watching. See you next time.